Assalamualaikum warahmatullahi wabarakatuh and hi everybody. Welcome to PMC 500 Statistical Reasoning in Education. I am Dr. Nur Asniza Ishaq, or also known as Dr. Ija. Today in this video, I'm going to explain to all of you regarding the concept of paired samples t-test. So previously, we have dealt with testing for the difference between two population means using the independent sample t-test. Independent samples are samples such that the selections of the sample from the first population does not affect the selection of the sample from the second population. That is to say, our samples are chosen independently of each other. Even the sample size for each need not be equal. Now, instead of independent samples, we are going to use dependent samples where samples are drawn in such a way that observation in the first samples are directly related to the observation in the second samples, or they occur as pairs of values. So these are examples of dependent samples, or we call it as paired samples. The first one, mean test scores for one group of students before and after receiving training. The second example would be mean blood pressure reading before and after receiving some medication. So if you look at this example, you can see the term before and after. So we measure the scores for the dependent variables before and after receiving certain interventions or training or medication or any other examples of treatment. So for t-test for dependent samples, it's also known as paired sample t-test, correlated group design, within subject designs, repeated measures, and many other names. But in SPSS, the term used is paired samples t-test. So now let's look at what does it mean by paired sample t-test, or also known as repeated measures design or within subject design. It's a design when you have two sets of scores from the same person in your samples. This means that each individual in one sample has corresponding individual in the second sample. Often, it will refer to the same person or organization or etc. So based on group of individuals who experience both conditions of variables. So when you do a paired sample t-test, it must involve the same group or same individual who are facing or who are experiencing same conditions of the variable. The participants measured before a treatment is applied and also after the treatment. So in paired sample t-test, it involves one categorical independent variable, usually measured before and after, and then one dependent variable. So you must remember, data must be interval or ratio or ordinal by choice. Assume distribution, where you need to know the normally distribution of the data. So in examples of paired sample t-test, you can do a research such as to determine the productivity level of each worker before and after a training program, to determine students' achievement using a new teaching method by having a pre-test and a post-test, to determine the effectiveness of a new slimming pill on a group of overweight people by weighting their weight before and after using the pills. So, like I said before, the keywords for paired sample t-test is before and after you give certain intervention. So what would be the assumptions that you need to fulfill in order to run paired sample t-test? First, variable is interval level, ordinal with cautions. Variable is normally distributed. Acceptable degree of skewness and kurtosis, or you can use Kolmogorov-Smirnov or Shapiro-Wilk. Or you can use central limit theorem, mean, mode, median. And additional assumption for paired sample t-test is that the difference between the two scores obtained for each subject should be normally distributed but it can be violated if the sample size is more than 30. Right, assumptions of normality, evaluating normality. There are both graphical and statistical methods for evaluating normality. For graphical method include using histogram and normality plot. And statistical methods include diagnostic hypothesis test for normality and a rule of thumb that says a variable is reasonably close to normal if its skewness and kurtosis have value between -1 and +1. In some cases, you can use -2 to +2. So assumptions of normality, we can use histogram and normality plot. So please take note the differences between the histogram on the left-hand side and the histogram on the right-hand side. So on the left side of the slide is the histogram and normality plot for occupational prestige that could reasonably be characterized as normal, because we can see some sort of like a bell-shaped curve. But time using email on the right is not normally distributed because we can see that the data is skewed. Now let's look at the QQ plot. If the dots are near the line, we can see that the data is normally distributed. Okay, now besides using graph, you can also test it using statistical tests. For example, using skewness and kurtosis. So the range of value for the skewness and kurtosis is between -1 to +1. In this case, the data is normally distributed as the value for skewness and kurtosis is between -1 to +1. And for the histogram, if it shows a normal distribution curve, it also means that your data is normally distributed. Like I said, besides you use skewness and kurtosis and also the graph, you can also use Kolmogorov-Smirnov and Shapiro-Wilk. What you need to know is that in order to get your data to be normally distributed, the p-value should be greater than 0.05. In this case, for both Kolmogorov-Smirnov and Shapiro-Wilk, the p-value is more than 0.05. To do PET sample t-test, you have to begin with hypothesis testing. So first, state the research question. Second, state the statistical hypothesis. Third, set decision rule, which is usually alpha 0.05. Calculate the test statistics. Decide if result is significant. And then interpret result as it relates to your research question. Let's look at a population of different score with a mean of 0. The null hypothesis in a repeated measure design is that on the average there is no difference between the two groups of scores. So this is the same as saying that the mean of the sampling distribution of different scores is 0. So for the hypothesis, null, and the alternative hypothesis, we assume that it is the mean difference is 0. So thank you for watching the video regarding the concept of independent sample t-test. In the next video, I'm going to show you some examples of using independent sample t-test. Thank you very much and have a pleasant day.